Students, can you see the slide? Students, can you hear me?
Yes, madam. Yes.
Yeah. Okay. Can you see the slides? Okay. Now, can you see the slides changing? Right. Okay. So, I think we that day discussed up to route also we finished that day, right? I think, yeah, right. So we have to start from IP address then, right? So now we have discussed about most of the devices. So we started from a modem, then the repeater, switch, and router, right? Hub, bridge, switch, and router. So now you know basic operation of all the different devices. So now we have to discuss a little bit about IP address, right? So how does a computer know whether the other computer is in its network or not, right? Now remember I told you, now when we do this kind of example, right? Right. I will just tell from here, right? So let's say I told you, right? So if this computer wants to send a packet to this computer, 3 passes the information to the layer 2. It tells the layer 2 that this computer is outside from our network, right? Remember I told you. So then the layer 2 of this computer, right? For example, if this computer wants to send some information to here, right? So then I told you layer 3 will tell the layer 2 that the computer that we are sending this message is outside from our network, right? So then it will put this default gateway's address as the next op and send it to here, and then from here the router will direct it to the correct path, right? Remember, I told you that, right? So when one computer wants to send something to outside, to our computer that is outside, you send the next stop address that is put is the default gateway, right? So that means the computer, by looking at the IP address, can understand whether this is a computer inside my network or outside my network, or are we both in the same network or outside the network, right? So that information can be gathered to a computer through the IP address of the sender, right? So when you have an IP address or any type of address, if you have, let's say, a hierarchical address like this, right? UOVT in Ratmalana, Colombo, Western and Sri Lanka, or you can have an address for university like this, right? Like our telephone number, right? Some number. So when you have, now this is kind of a hierarchical address, right? So there are different steps here. But here you have only one digit, right? So which one is better? If you want to, looking at the address, if you want to understand where this computer or where this building is exactly at, right? So which type of address is better? This kind of hierarchical address or a flat address? If you want to understand where this location is from the address, the first one or the second one? Yes, what do you think? Our requirement is by looking at the address to identify whether, now let's say another person in Colombo, right, wants to send a letter to the university. So then looking at the address, he should be able to understand if there is a requirement that the person sender has to understand whether this is in Colombo or outside Colombo, or whether this is in Sri Lanka or outside Sri Lanka. So if you use this kind of UOVT, Ratmalana, Colombo, Western Province and Sri Lanka, that kind of address, that is a hierarchical address because it has different steps, right? Or you can use this kind of some random digit. Which one is better? If you want to identify the location from the address?
Second one.
Second one. Why? Why you say that? No, just forget for a moment that this 94 and 11 have a meaning. If you have a meaning, then that is also again a hierarchical address, right? I'm asking just if you have just a number for a university, then another number for your home and another number for your school. Like that, if you have numbering system, some random numbering system as addresses, or this kind of system, which one is better?
First,
Why do you say the second one is better? Somebody said second one is better. Why? You thought about this country code and city code like that and told, or actually first one is better, right? Because in first one, by looking at, you can understand, okay, this address is in Ratmalana. If somebody don't know about Ratmalana, then looking at this, that person can understand, okay, this is in Colombo, right? So if somebody who doesn't know even Colombo, Ratmalana, if he knows about the Western province, so from there he can take an understanding. Or if we are talking about somebody who is looking at this address from outside of Sri Lanka, so then the country, if you want to first identify the country, that is there, right? So this kind of hierarchical addresses always better if you want to route things, right? If you want to send, if you want to find the way to where it should go next, by looking at the address, if you want to get that information, then hierarchical or like you have different level addresses are better rather than having a random number, right? So what information would the routers need to route to Ethernet address, right? So when you want to send the packet to a certain place, what are the information the router will need? It needs the hierarchical structure of, right? So there should be, now looking at the address, right? Like this. Now looking at the address, you can understand, okay, first of all, you have to go to Sri Lanka, and then from there you have to go to Western province. And from Western province, in the Western province, you have to go to Colombo. In Colombo, you have to go to Ratmalana. And in Ratmalana, you have to go to University of Vocational Technology, right? So there is a way, right? So looking at the address, you can find the route, right? First to Sri Lanka, then to Western province, then to Colombo, like that, right? So that is what is said. Need a hierarchical structure for designing scalable binding from the interface name to the route, right? So from this IP address, there should be some relationship to the route or the path that we have to take, right? So that is the basic requirement. The router needs to look at the IP address and understand where this should go next, right? So that information should be able to gather from the IP address that we are providing. Right. So in the hierarchy, you have to know how many levels, right? So what are like country, province, like that what? Same hierarchy or depth for everyone, or so all the addresses should have something, the same structure, or sometimes there may be addresses where you don't have all these levels and some levels only, right? So these things are also important, right? Now, have you seen IP addresses before? Right. That day I showed you, right? From my computer, I showed you the IP address, right? So to take IP address, just we'll try one more time. Give me one. Hope you can see this command prompt. Okay, so this now shows the IP addresses, right? So here you can see for the different connections, the MAC addresses I have, but these ones we don't get the IP address because I'm not You can see this command prompt, right? Can you see this command prompt? Students, can you see this black color screen? Yes, right. Okay. So here in the first ones, right? First connections, Ethernet adapter, local area network 1, 2, like that. Those connections I am not using right now, right? So because of that, only the MAC address is given. But for the IP address through Wi-Fi, right? Because I am connecting now to the Wi-Fi, it is given here. So you can see this is my IP address, right? Now we will learn later. I will just show you that also. Now we have two addresses. We say we have IPv6 address and IPv4 address, right? So these are two versions. IPv4 is what we use now in the world, but we now all the computers are anyway in the network given IPv4 and v6 both addresses, because there is a plan for the world to move from v4 to v6 in near future, right? Why the reason we will learn later, right? We will discuss today. So usually we have IPv4 and IPv6, two addresses are there now in any network connection, but for the time being, what we are using is IPv4, right? So if you see here, it has how many components? You can see one number dot, another number dot, another number dot, and another number dot, right? So the maximum number you will see in any of these is 255, right? 255. So you will have four components like this, right? So this is the IP address, right? Then right, hope you can see the slides. So in this IP address, it has 32 bits, right? Why do I say 32 bits? If it is the maximum number you can take in one is 255, right? If you convert 255 to binary, how many bits? 255 in binary bits, how much? How many? 2 to the power 32, sorry, 255 means 2 to the power, what, which one? 256 is?
7.
1, 2,
7.
yeah, 1, 2, 4, 8, 16, 32, 64, 128, 256, right? Right? So that means here you will get 8 bits, right? So one number is represented by 8 bits. So what we actually give here is 8 bits, a dot, another 8 bits, a dot, another 8 bits, a dot, and another 8 bits, right? So because we cannot easily tell this number, like communicating in binary is harder, we have converted into decimal and shown like 128 or something like that, right? So but the IP address you will see is something like 128.10.1.5, something like that, right? But actually this is a 8-bit number, right? This is another 8-bit number, this is another 8-bit number, and this is another 8-bit number. So when you take everything, all the 8 bits in 111111, the value you will get is 255, right? So that is why one number, the maximum value I told you here you can get is 255, another 255 like that, right? So basically it's a 32-bit value, but we show it for our convenience for the humans, because we are more like convenient with decimal values. We say it in 4 decimal values with dots, right? Actually it is a 32-bit number, right? So IP address, now if you take these 32 bits, it has a network part and a host part, right? So if you take this IP address all together, right? So there is a way, one part is given as the network address and the other part is given as the host address, right? It is like this. Now, let's say you have address like this, 128 Samagi Lane, right? And then you have another address, 256 Samagi Lane, right? And another address, 125 some another place, right? We'll say first lane, right? Now, if you see these addresses, you can see two components, right? There is one component, the number of the house, right? And the other component is what? What is this component? This component is the number of the house. This is what? Address, the street address, right? Or the road address, right? So when you have this kind of address structure, when you look at these first two addresses, what can you understand? Looking at these two addresses, can you understand any similarity between the two houses? What is the similarity? Yes?
Both are in same lane.
Both are in same lane, right? But two different numbers, right? But if you see these two addresses, second address and third address, you can understand what? They are in two different lanes, right? Two different roads, right? So you can understand if you have this structure, house number and a street address, from that you can understand whether they are in the same one or different one, right? So that is exactly what we do in IP addresses also. So when you take an IP address, this whole 32 bits is divided into a network part and a host part, right? Network part and a host part. So from looking at that, the computers can understand whether these two computers are in one network or two different networks, right? So the IP addressing system is basically having one network part and one host part, right? So initially, when we started the IP addresses, they had a classful structure, right? What do you mean by classful structure? All the IP addresses were divided into few classes, right? Few classes. So all together there were about 4 billion IP addresses. So those IP addresses were divided into few classes like class A, class B, and class C, right? So we will, right, give me 1 minute. Huh? The IP addresses were divided into few different classes, right? Like class A, B, C, like that, right? So we will see what is this class A, B, and C. So if you have class A, class B, class C, class D, and E, very easily you can identify whether this is a class A, B, C, D, or E number by looking at these first digits, right? So if it is a class A, always start the first digit is 0, right? First digit means not the first number, right? So not the first number. In this number, I told you there are 8 bits, no? So out of those 8 bits, the first bit is always 0 if you are a class A IP address, right? And then class B starts from 10, class 3 starts from 110, class D starts from 1110, and class C starts from 1111, right? Right. So basically, generally normal networking, what we use is class A, B, and C, and class D and E are reserved for special purposes, right? So usually in the networks, what you will see as IP addresses will be either class A, B, or C, right? So how do I identify it? By looking at the first 2 or 3 few digits of the IP address, binary digits, you can understand whether it's A, B, or C, right? And the other thing is, if you are a class A, your network part, I told you, every IP address has a network part and a host part, right? So your network part only contains the first 8 digits of the IP address tells you the network ID in class A, right? And the other part, all these now 32 minus 8 is 24, right? So all that 24 digits are reserved to tell the host ID, right? Host ID means, remember in my early example, I told you the house number. Like in a lane, there are so many houses, we give numbers, right? So then all these 24 digits are assigned to give the house number, right? And then in the class B, we use 16 digits for the network part and another 16 digits for the host part. That means the computer number or the host ID, right? In class C, we use 24 digits for the network part and only 8 bits, 8 digits or 8 bits for the house or the host ID, right? So in the class A, B, and C, the major difference is the length of the network ID and the host ID are different, right? If I summarize one more time, in class A, we use 8 digits for the network ID, which means you have 24 digits for the host ID. In class B, we have 16 digits for network and 16 digits for host, right? In class C, we have 24 digits for the network and 8 digits for the host ID, okay? Right, give me 1 minute, student. If you want to note down anything, you can note down.
Recording stopped. Recording in progress. Recording stopped. Recording in progress.
Okay, sorry students, today because of the weather, I may get disconnected several times. So if so, please wait, I will join again, okay? There is an issue with the network today. Right, so hope you can see the slides now. Right, so this is, you can see the slides, right? Students, can you see the slides?
Yes,
Yes,
ma'am.
madam.
Right. So now, as I told you, in the network, in the 4 classes, the main difference is the length of the network ID and the host ID are different. Right. Now, why do you think we have this kind of 3 types of classes? Now, let's say if there is a road, right? Now, just assume if there is a network where you have only few computers, right? So then what type of host ID is required? Do you need large number of digits for the host ID or you need only small number of digits? Let's say in a computer, in a network, we have about 25 computers, right? So 25 computers means we need only 25 different host IDs, right? So then in that kind of situation, the number of digits that we need for the host ID, should it be a large number or a small number? You need only 25 different addresses, right? So 25 different, in order to take 25 different addresses, how many digits you will need? Right, it's like this, no? Let's say we have only 1 digit, then what are the addresses we can have? If you have only 1 digit, 1 and 0, right? Correct? So if you have 2 digits, we can have 1, 1, 1, 0, 0, 1, and 0, 0, right? So if you have 2 digits for the host ID part, we can have 4 different addresses, right? Like that, if you have, let's say 3, so if you have 3, you can say 1, 1, 1, then 1, 1, 0, right? 1, 1, right? 1, 0, 0, 1, 0, 1, right? Like that, you can have how many? If you have 3, 2 to the power 3, right? 2 to the power 3 is how much? 8, right? So then you can have 8 now, 8 different addresses, right? Understood? So if you, the length of the host ID, right? The length of the host ID will tell you how many different addresses you can have, right? So if you have only 1 digit, then we can have only 2 addresses, 1 and 0. If you have 2 digits, we can have 0, 0, 0, 1, 1, 0, and 1, 1, right? Like that. So the number of host ID digits will tell you how many different addresses you can have. Now, my question is, if you have only few computers, right? Let's say you have only 10 computers, then how many different addresses you need? How many different addresses you need if you have 10 computers? Yes? How many you need?
1024.
No. I'm just telling in a network, you have only 10 computers, only 10 computers in the network. So how many different addresses you need if you have 10 computers? 10 addresses, right? So 10 addresses means how many digits you will need? If you need 10, if you have 3, we can go up to 8, right? If you have 4, you can have 16 addresses, so right? So that means using only 4 digits, we can give the addresses, right? But if you have, let's say 100, right? If you have 100 computers, then we need 100 different addresses, right? So then that means we have to go to 128, which means 1, 2, 3, 4, 5, 6, 7, right? So you will need 7 digits, right? Like that. Now this host ID will tell you how many, the length of the host ID will determine how many addresses you can take, you can have, right? So then can you tell me, can you guess why we have this class A, B, and C addresses? Class C addresses are for which kind of network? Class B addresses are for which kind of network? Think about the number of computers. For example, if you have a small network, will you need a class C address or a class B address? Yes? What do you think? Now we learned when the why?
Class B.
Class?
B.
I'm asking B and C, okay? B for Ben, C for cat. If you have a small network means you need only less number of host IDs, right? Host IDs are the house addresses or the computer addresses, right? This is for the network part now. The blue color part is for network. Green color part is for the different computers. We have to give a different number, like Samagilen 128, Samagilen 200, Samagilen 100, Samagilen 5, like that. That number is this host ID, right? So if you have a small number of computers, that means your number of host IDs required is large or small. If you have small number of right? So small. So then that means the length of the host ID should be what? Larger or smaller? Smaller, right? Which means you need which class? Class C or B? C, right? So class C, right? So for smaller networks, we can use class C, right? So class C means you have 8 digits, which means you can go 255 addresses, right? So if your network is usually having more, like let's say around 200 or 220, because we need some additional addresses for different purposes as well. So let's say your network is around 200 or less than that, then class C address is enough for you, right? But if your network is a larger network, let's say 500 computers or 1000 computers, then we cannot use class C. Why? Because you can have maximum only 255 host IDs. So you can have only maximum 255 computers, right? So then you have to go for a class B or a class A, right? So, but here, the other thing to note, now if you look at the network ID, right? So in a class B address, how many different networks you can have? In class C, how many different network IDs you can have? Like network IDs like let's say that in my previous example, that how the lane, right? So different lanes we can give, right? So here you have larger amount of bits for network ID, right? So that means we can define many number of networks, right? In class B, but the network ID only has 16, right? So that means you can have only 2 to the power 16 networks in class B, different networks, right? So in class A, you have only 8 digits. That means you can have only up to 255 networks, right? So that is what I mentioned here. In class A, you can, because you cannot go 255 because here the first number should be 0, right? So then you can have only 128, right? So that you figure out later. So basically idea is in class A, you can define less number of networks, but in that network, you can go up to 16 million hosts, right? In one network, you can define 16 million host IDs, which means these are used for very large networks, right? Class B, we can have about 16,000 different network IDs and 64,000 hosts, right? So medium-sized networks usually have class B type of addresses. Class C means we can go up to maximum 256 devices, but you can have different class C addresses, 2 million, right? Why? Because in the class C, the network ID part is lengthier. So any questions up to what we discussed now? Up to what we have discussed? Any questions? So it is clear, right? What is class A, B, and C? What is the difference, and where we are using class C, where we are using class B? It is clear. Right, so I told you from the first number or the first 8 bits, we can identify which is whether it's a class A, B, C, D, or E from looking at these digits, right? So from starting these digits means class A, the first number, the first dot number will be 1 to 126. That means it will be something like 125 dot or 1 dot or 10 dot like that, right? So if you have the first number from 1 to 126, it's a A. 128 to 191, it's a B type address like that, right? So how we are defining that? Because in class A, always first number is 0, right? So here you can go up to 1 to 128 technically, but there will be 2 reserved for other purposes, right? Like that, right? So from first number, you can identify whether this is A, B, C, D, or E, right? So that is another thing. So don't worry, you don't have to remember all these things, but you have to have the idea, right? What is this class A, B, and C? What is it doing? Those things you have to have an idea. Right. So to make it converted to a decimal, right? The length of the network bits is given as a prefix, right? So usually, now if you have, this is the 32-bit, it's a class C address, so the network bits will be 24, right? Remember, class C means 24 bits for network ID, right? Network ID is having 24 bits. So usually if you see this kind of thing, 192.068.1.5./24, this /24 means first 24 numbers is network ID. So first 24 numbers means first 3 decimal numbers. 24 means, remember the digits we are talking about, right? So if you have this kind of one, this is giving you the length of the network ID. Okay. Is it clear? So if you see a number like this with /24, that is giving you an indication 24 digits are used for network, right? So 24 digits means 3 decimal numbers, because we are using 8 digits for 1 decimal number. So this part will be the network part, and only this final number will be giving you the host ID. Okay, is it clear? Right. So now here is an example for you. Can you try to do this? For easiness, I will take this picture also here. Right. Right. So please try to do this example. Find what is the IP class of the below IP addresses, and also find out what is the host ID and what is the network ID. Okay, I will give you about 2-3 minutes. Please do this. Okay, can we discuss now? The first one. What is the class? You can find out from here to refer to this. Right, so this is giving class 1 starting from 1 to 126, class B 128 to 191, like that, right? So that means first one, what is the class? You can look at the first number and tell. 15.23 means what is the class? Yes? Students, is it clear how you have to do it? Or you have a question? You don't understand?
Class A, madam.
Class A, right? Because it is starting from 1, it's in the range of 1 to 126. Class A. So then what will be the network ID? What is the network ID? Network ID, first 8 digits. In class A, that is first 8 digits, which is what? What is the network ID then? 15, right? So the first number is the 8 digits 15, right? So second one, B, starting from 178, which means which class? 178.
B.
Class B, right? So then network ID is? No. How many, class B, how many digits are used for the network ID? Look at the picture.
16.
16 digits. So that means what is the network ID? 16 digits means how many by decimal numbers? First one is 8 digits, second one is another 8 digits. So that means what is the network ID? 178.56, right? Because you need 16 digits, which means 2 decimal numbers, right? 178.56, right? Third one. What is the network ID? $20, right? Because class A, first it is a class A, then that means you are only using 8 digits, which is 20, right? So fourth one, D, 192. 192 means it's a class C, right? Class C. Then class C means what is the network ID? 100, no, not 15, up to 15 everything, right? 192, yes, 15, right? That is the network ID. Then host ID is 221, right? E, 224. 224 means it's a class D, right? Right. Class D, we don't have a separate network ID and host ID because it is using for different purpose, multicasting addresses, right? Remember, I told you when you want to send a broadcast message, there is a specific special IP address we use. The same way, there is something called multicasting, which is little bit like advanced, where you want to send some messages for only selected computers. So then we use something called multicast, right? So for that purpose, we use the class D addresses. So because of that, you cannot say in a class D address, this is the network ID and host ID. It's a different thing. So you can just write it's a class D address, right? So is it clear? This question, anything anybody wants to clarify? Right. Now there is a, now although I said we use classes, right? Here I told you initially when we started the IP addressing, we started in this classing system, right? So we say this as classful addresses or classful structure, right? Where you have different classes for IP addresses. But there are a few problems in this, right? When the network grew, right? When the network grew, there were some the problems identified with the IP classing system, right? So you have only about 2 into 32, 2 to the power 32. That means about 4 billion addresses, right? So we have a limited number of addresses. So out of that addresses, first, right, the IP addresses were assigned on request, first come, first served basis, right, rather than on requirement, right? So first of all, when the IP addresses, there is a separate organization authorized to, assign IP addresses for the networks in the world. So when you first started IP addressing, there was no requirement to like utilize the IP addresses as much as possible, because at the initial time there were only limited amount of computers and 4 billion addresses were more than enough, right? So at that time, IP addresses were given on an ad hoc basis, right? When somebody asked for an IP address, you were given, right? So because of that, in the networks, which were the earlier networks, they have IP addresses. But when the network grew, there was so much demand for IP addresses, and there were problems about giving IP addresses, right? For example, let's first look at an example like this. Let's say an organization is given a class B IP address, right? So when the first was given, when first IP addresses were given, they were given freely, right? You didn't consider anything. Now let's say you have an IP address or network ID class B, right? So that means how many host IDs you can use? How many host IDs are there for you? Class B means how many bits are we using for to represent the host ID?
16.
16, right? So that means you can go up to 2 to the power 50, 2 to the power 16 host IDs, right? Right. But if your network is only having about, let's say, 1,000 computers, right? So that means what? What is the problem? Are you using all the IP addresses given to you? 2 to the power 16 is a large number, right? So you are having only 1,000 computers, right? So that means what is happening? Are all the IP addresses in this like, let's say you have some network ID, right? Network ID, let's say something like 178.60 is your network ID, right? So you can have 178.60 and some numbers, right? So you can have 16 digits, which means you can go up to 2 to the power 16 different IP addresses, right? Which is a large number. But you only need 1,000, right? Because you have only 1,000 computers. So then part of the addresses is what? They are not utilized, right? Do you understand what my point? Now let's say we'll take an easy example for you to understand, right? Let's say this network 192.168.15.221, right? So this is a class C, right? 192, let's go and see. Class C, right? So it's a class C address. So this network, right? This organization is given a network ID. You are given a network ID. No, this is your network. You are given a network ID 192.168.15. Right. So that is your network ID, right? So how many different addresses you can have here? 192.168.15.1, 15.2. Like that, how many, up to how many you can go, I told you? How many different addresses you can have? 190.168.15. How many addresses?
8.
No, not 8. You mean you can go only 192.168.15.1, 15.2, 15.3, only up to 8? What is the maximum number you can have here? The last number, what is the maximum number you can have here at XXX? Yes? 255, right? So that means how many different addresses your network can have? 192.168.15.1, 2, 3, 4, like that. How many you can go? Students, you need to answer. How many addresses, if the maximum value you can go in this final number is 255, I'm asking you 190. Now your network name is 192.116.15.15. That is the network. Then you have the computer number or the host ID, right? You can go 1, 2, 3, 4, like that. Up to 255 you can go, no? Because 8 digits means 255. All 1111 is 255. So how many different computer addresses you can have in this network, in this structure? $255, no? 192.668.15.1. Again, same thing, dot 2. 168.15.3. 150, like the whole thing, right? 192.168.15.4. 192. Blah, blah, blah. 7, 8, 9, 10, like that. You can go 255. So how many different addresses you have in your network? How many different addresses you have for your network according to this system? 255, right? So if you, let's say you have only 10 computers in your network, your maximum number of computers in your network will be, let's say, 15, right? So you give one computer 192.168.15.1. Next one you give 15.2, 15.3. Like here you can go 15.15. Then all the addresses you need are given. Then what will happen to the other addresses? Can any other network use them? Can any other network use them? What do you think? So the next address will be 192.168.15.16. 192.168.15.20. Those addresses, can you give it to some other network saying we have only this number of computers, so we don't need these addresses, so I'm going to give them to other people. Can you go give that like that? Students, can you give like that?
No.
No. Why? What is the reason? It is like this, right? Let's say Samagi Lane, you have only 20 houses, right? So you say number 1 Samagi Lane, number 2 Samagi Lane, like that, number 20 Samagi Lane, right? So now because another lane, there are 100 houses, can you give one address like 25 Samagi Lane to that other road house? Can you give like that? No. Why? Because the network ID part has to be specific to your network, right? So once you are assigned a network ID, right? Although you have unused host IDs, you cannot, in this class system, class full structure, you cannot utilize them for another network. What is the reason? Because now this network ID part is fixed, no? So either you can select 8.1 or 16.1 or 24.1, right? So although you have only less number of host IDs, you don't have a system where you can have, let's say, 6 digits for the host ID and others for the network, right? So then you are utilizing, because these other ones you are not using unwanted number of host IDs or unwanted number of host digits, right? But in the class full system, because this is fixed, these lengths are fixed, you cannot adjust like that, right? Either you have to go to this one or this one. So in between, there are no in between ones. So the lower than this also not there, right? So because of that, there are so many unutilized IP addresses, right? But at the beginning, it was not a problem because there were so many IP addresses and less number of devices. Now, there are so much of issue because there are now lot of medium scale networks, but those networks don't have enough number of addresses, right? For example, let's say medium scale means here, right? So medium scale means class B addresses you can have only up to 16,000 networks, right? So class B system, we have only 16,000 different network IDs, right? But actual requirement is more than that, right? But because now already a lot of network IDs are already given to different networks, now the new networks have a problem of not having enough IP addresses, right? So anyway, you can see when you have this kind of like rigid limit about the network IDs and host IDs, there is an issue when you want to define the networks, right? So because of that, we came to something called the subnet mask, right? Or later there was another system coming, or another system introduced to divide one network ID to different networks again, right? So if you have one network ID and there you have so many different host IDs, like let's say you have a network ID with 1,000 host IDs, right? But you only need 200, right? So then about another 800 host IDs are remaining, which are not utilized. So what we are going to do is you use one network ID and then again divide it into again 3, right? And you use this for one network, this for another network, and this for another network, right? So this system was introduced to solve that problem of having not enough IP addresses for different networks. Okay, so that is what is given, what is spoken or what is introduced as subnetting. So you have one network ID and you take that network ID and further divide into 3, right? And assign one network ID plus subnet to one network, another subnet to another network, and another subnet to another network. So one network ID now you can share between 3 different networks, right? So we'll see how this is happening. Right. So now earlier we had the network and the host, right? Network ID and the host ID. Now we are using with this network, the host part is again divided into subnet part host, subnet plus host, right? So you have a subnet part and a host part. So this subnet part is used to define those different networks, right? Now let's say it is like this. Let's say you have one IP address. This IP address we are going to share between, let's say network 1 or network M, network N, and network O, right? All these 3 networks are going to share this A network, right? So this part will be A. This network will be A. This part will be either M. You will tell here whether this is M, N, O. And then this part will tell you the host ID or the computer ID. Is it understood? Now let's say you have one network ID, right? I have been given a network ID class C, right? So maximum I can go up to 255 computers. But my network is only having about 50, right? So I'm having 50 means I'm not utilizing about another 200 addresses. So now what I go on to do is I am this organization, M organization. I'm going to share this with N and O, right? So then what I will do is, now usually network ID is A, then that part is not going to change now because that is already assigned to us. So we are going to use this additional some amount of bits here, right? To tell whether this should go to M, N, O, right? So this part will tell you whether you are in M, N, O, then A in network A, network M. Then next one, network A, network N. Next part, network A, next network O. And so this part is actually the network ID now. Network plus the subnet is actually the network. So we are using few numbers for the host IDs because we have only limited number of computers. So what we are actually doing is converting part of the host IDs also to a network name so that we can use one network ID and share it between 3 or 4 different networks. Is it clear? What are we doing in this subnetting? Is it clear? Is it clear, students, what we are trying to do here? Any questions? Right. So let's then try this question. If you don't understand anything, please ask, okay? Because otherwise, later it is very hard for you to gather after doing it, right? So please, if you don't understand anything, please ask. Right. Right. So please write down this question. Okay, you can do the part A, B, and C. Then I will tell you how to do the part D. Okay. First try part A and B are very easy, right? So then think about part C, what you can do. Okay, can we discuss? Right. So your organization is given 192.15.10. So that means this part is fixed, right? 192.15.10. Sorry, 192.15.10 is fixed, right? And then you have how many digits? 1, 2, 3, 4. You have, let's say, X, 4, 5, 6, 7, 8 digits that you can change as you want, right? So this part you cannot do anything, right? So this part is already assigned to you. You cannot do anything with this part, but these 8 digits, you can do whatever you want, right? So the first, what is the answer for the first question? How many host IDs we can have? So if you have eight digits to play around, how many host IDs you can have? Yes?
255.
255, right? So the first question answer is 255, right? So your organization has only 100 hosts. How many host IDs are required for your organization? So out of these 8 ID, now you have 8 digits to place, right? How many actually not host IDs? Please correct this as how many host digits you need, okay? Sorry, host digits. How many host digits are required for your organization? So if you have 8, right? You have 8 digits, but you need only 100 different IDs or 100 different addresses. So how many host IDs are required actually? So if you have 1, you can go, you have 2 IDs. If you have 2, you have 4 IDs like that. To have 100, that means you can go, the option is 128, right? So to get 128, how many IDs you need? How many digits you need? 2, 4, 8, 16, 32, 64, 128. How many you need? 7,
7.
right? You need 7, right? You need 7. So that means 1, 2, 3, 4, 5, 6, 7, right? Right. So I have made a small mistake. Sorry, my mistake, student. Can we make a small change in the question? Please make the change here because I have made a mistake. We'll make this as not 100. We'll make it as 64. Right? Please make this as 64. Sorry, yeah, that's my mistake. Right. We have only 64. Let's say 60 hosts. Right? You have only 60 computers in your network. Right? So if you have 60 computers, that means how many digits are required? So 60 means we have to go to 64. That means we need only 6 digits, right? So 1, 2, 3, 4, 5, 6. These 6 digits we are going to use for the host ID, right? So see, now we have remaining 2, right? So this remaining 2, what can we do, right? Now you have this IP address, this part we cannot change anything because that is already given to you. You don't have any authority to do anything. But using these 2, right, you can convert this one network ID into, now this is 192.15.10 is given. We cannot do anything. But we can change this, right? We can change this. What are the options we can have here? Yes, what are the options we can have? We can have 192.15.10.11 and then XXXXX, right? Then we can have 192.15.10.10.10 and then XXXXXX, right? Then 192.15.10.11 01 xxx xxx, right? Then 192.15.10.00 xxx xxx. See, right? So we need this xxx part is to give to the host, right? Because we have about 60 hosts. So if you have two similar organizations or who are also having about 60 computers as hosts, then what we can do is we can share this network ID plus this part, right? For one network, right? Now, first network, we are going to use 192.15.10.11xxxx to one network, right? 192.15.10.10 xxxx to other network. 192.15.10.01 xxx to other network, right? Like that, you can share this one network now between how many different networks if you want? 4 networks, right? You can, from this one network ID, now we can create 4 networks, right? So that is what is called subnetting, right? So you decide to share this 192.15.10 with 2 other networks, then show the host ID length and the subnet part. So this part, right? This part that I have shown in this purple color part is called the subnet, right? So this is called the subnet, right? Then we are asking what is the subnet mask that can be assigned to each network, right? So subnet mask means this. What we do is now the network ID now we have is 192.15.10. Now that is common to all 3 networks, right? So we call or subnet mask or network mask, right? So that means we are going to now create 3 different subnets or 3 different network IDs from this. So one will be, what we are going to do is you put everything to 0 here, right? So let's say 192.15.10.11.000.000, right? So this number, there will be some number. No, what is this number? Can somebody tell me? Convert to decimal and tell me. 11000000. What is that? First one is 2. So first one means 256, right? Sorry. Not 256.
192, madam. Yes, yeah, no,
The final value is 192.
yes, madam.
Right. Yes, okay. It's 10.192, right? So this is the network ID of the first one, right? 192.15.10.192 is the network ID of the first network, right? Next one is 192.15.10.10. Now 10, right? 10, so that is the network part, and then we can put all as 0 to get the network ID of the next one, right? So that will be 192.15.10.128. First one means 128.
Yes, madam. Yes.
Yes, right. 128, right? Next network 192.15.10.01, right? 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, right? So that means 192.15.10.64, no? Yes, 64, right? Like that, okay? So you can get now first net,
Yes,
now,
madam. 64.
yeah, 64, right? So if you want another network, then that will be 192.15.10.0, right? So see here, I will write the other one also, but in the question I have asked only about 3, right? 15.10.0000000. That is 192.15.10, 192.15.0, right? So there you can have 192.15.10.1, 2, 3, 4, like that, up to 63 will be given for the first network, right? The next network, the network ID is 64. So you can start 192.15.10.64. We are usually not using. Then 65, 66, 67, like that you can use. Next one, starting from 129 addresses you can use. Next network you can use starting from 193 up to 255. Right? See, now we have converted this one network ID that was given to use in 4 different networks that is having maximum about 60 hosts. Right? So this is called subnetting. Right? Earlier, we about 255 addresses were there, but the network only used 60. Right? And all other ones you could not use. If you are using this strict classful addressing, right? You say, okay, this is the network ID, so you are not going to change that. So that is called classful addressing. In classful addressing, a lot of network IDs are unutilized, right? So then you can use this subnetting technique to use those unutilized IDs by taking part of the host IDs as a subnet and then create different network IDs from one network ID that is assigned to one network. Right. So hope it is clear. Any questions? Right. Please write this down. And if you want to make any notes of what is happening, also you can write down. So basically the first network can have 192.15.10.1, 2, 3, 4, those ones. Next network will start from 65, 66, like that. Next network will start from 129, like that. And the next one will start from 193. So this one network can be now shared by 3 different networks. And looking at this first number, this number now, you know, if it is more than between 0 to 64, network 1, 64 to 128, network 2. Like that, you can determine which network this is belonging to also from looking at the network ID. Right? Any questions? Because I want to the other part. So if you have any questions, please ask now. It's clear? Right. Any questions? So, right. So we will go back to the slides then. Right. So this is that same kind of example, right? So if you convert, how many hosts do we need? That same type of example, right? So as I told you, usually now, although you have 2 to the power 7, right? Now let's say you have 7 hosts. That means you can have technically 2 to the power 7 IDs, right? But out of that, we take out 2, right? So usually if you have 7 bits, we say you have 2 to the power 7 minus 2, 126, because we are not using 2 addresses because one is for broadcasting and the other one is for that network ID, right? So because of that, usually you have to take out 2 and the other ones you can use as the host ID, right? So then you have something called the network mask, right? Network mask means 192.15. Previous example, Students, can you hear me? 10, right? And then we use 2 digits, no? Right. Let's say 1, 1, right? 1, 1, 0, 0, 0, 0, 0, no? 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, no? So let's say this is your network, right? So for this network, there is something called subnet mask, right? Subnet mask is used to for the computer to identify which network you are coming to, right? From network, which network you are coming to. Subnet mask means we take all these network ID bits to 1, right? That means 1, 1, and then dot. We are not going to put the dot, right? I'll keep a space. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, then 1, 1, right? We are going to show all the network bits as 1, right? So this is called the subnet mask of the network. In that previous example, this is the subnet mask. Please write this down, okay? Subnet mask is this. What we are going to do, you are going to convert all the network bits into 1, right? Then the answer you will get is something like 255, 255, 255. 1, 1 means 192, you said, no? 192, right? So this is the subnet mask of that subnetting system, right? 1, 1, 1, 1, 1, 1, 1, 1, 1, everything, all the network bits, when you convert into 1, 1, then the value you will get is called the subnet mask, right? To find the subnet address of IP address, perform an operation of IP address and network mask. Right. Now, for example, let's say one of the IP addresses of your system is 192.15.10. Let's say 198, right? So this is the IP address. Now 192.15.10. Now there are 4 networks actually, no? Because remember we divided it into 4. Now the computer wants to understand, or the router wants to understand, what is your network ID, right? Which network you have to go to, network 1, 2, or 3, or 4, right? Whether you have to go to 192.15.10.0 or 10.64, no? Next one is 64. Yeah, 64, like that, which network this computer is belonging to, right? To do that, what you have to do is you have to take the IP address and the network mask, right? So you have to take this network mask or the subnet mask and then do an AND operation, right? When you do AND operation, you will get the network mask, a network ID, or the subnet address. Is it clear? Is it clear? Can somebody tell me the network IDs that we created from that subnetting example? 192.15.10.01, no? Students, can you tell me? Because I cleared that, no? 192.15.10. What was the next one? 64. Huh? 64. Right. Next one. $128. Last one, 192, no? Is this clear? Sorry? 192, right. So now these are the 4 networks, right? Now these are the 4 networks you have. Now out of these 4 networks, you want to identify which network this is coming to. Now remember, this is not coming as these decimal numbers, no? So if it is coming as a decimal number, I can directly say, okay, this has to come to this network, right? But these are coming as binary numbers, right? So then the computer has to understand which network, whether this IP address is in this one or this one or this one or this one, right? So to do that, what you do is, AND operation, and right? One and 1 is 1. 0, 1 and 0 is 0, like that AND operation. So you do AND operation of this IP address plus this subnet mask, right? So you convert this IP address into binary, and with the subnet mask, you do AND operation, right? So then you will get the network ID. This network ID you will get as the net mask, right? So how to get the subnet mask? You have to convert all the network bits into 1, then you will get the subnet mask. Is it clear? Any questions about subnet mask? Any questions about subnet mask? Subnet mask means you convert all the network bits in the network to 1, right? So then you will get the subnet mask. So you do AND operation with the subnet mask and the IP address, then you will get the network address or the subnet address. Okay, even this is your IP address 192.168.1.5, right? Subnet mask is 255.255.255.0. Then you need to find out what, let's try to find out the network ID. We'll try to find out the network ID here. Right. Can somebody quickly tell me what is 192 in decimal? First, I'm going to write the IP address in decimal, okay? 192 is what?
110000.
11000000, right? 1, 2, yes, okay. Yes. Then 168. 168 means 128. One zero one. Okay, right. Others again 1. Eight, no? Okay. Right. Then 1 is 0, 0. Okay. 1 is that, right? And then 5. 5 is 4 plus 1, no? So then 0. 5, 6, 1, 0, 1, right? That is correct, right? 5. This is 1, then 2, then 4. Is that clear? 5. Right. So this is our IP address, right? And then we'll write the subnet mask. What is the subnet mask? 25555 means 1. Everything is 1. 1, 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, I have not written. Right. The next one, again 255. 1, 1, 1, 1, 1, 1. Right. Again 255 means right. Then 0 means 0, 0, 0, 0, 0, 0, 0, 0. Right. Right. So this is now you have to do AND operation, right? What do you mean by AND operation? If 1 and 1 is 1, 0 plus all others are 0, right? Is it clear? AND operation? 1 and 1 is 1. See 1, 1, or if both are 1, you get 1, others all are 0, right? So first digit is 1. 1 and 1, 1. 1 and 1, 1, right? Then all others are 0. 1, 2, 3, 4, 5, 6, right? Then next one, again, 1. So 1, 0. Correct? This one 1, this one 0, again this one 1, this one 0. Right, right, correct, right? And then next one, all are 0 other than last one, no? 1, 2, 3, 4, 5, 6, 7, 1. Next one, again 0, 0. Okay, all are 0 because you don't have ones, no? Right. So then this means what? 192, yeah, dot 168, 1.0, right? 1.0, right? So this is the network ID, right? So see here, this is actually, they have divided exactly at the, because here, no, this is the subnet mask, right? So all these as 1 means they have clearly divided at this part, right? There are no network parts in the final 8 digits, right? So that means your network is starting from here, right? This part is network ID, this part is host ID. So the network ID is 192.168.1.0, right? And the network, the computer is 192.168.1 is the network part, 5 is the host ID, right? So basically, by doing an AND operation of IP address and the subnet mask, you can get the network ID, right? So that is how when you get a network IP address, usually with the IP address, the subnet mask is given, right? The subnet mask is given like this, right? So from doing a AND operation between these two, any router can figure out what is the network address, right? So then they can find where their network address is and then route it to there, right? So either you have clear cut of network IDs at this point, or you use some network points from here. By doing this operation, you can clearly find out what is the network address, right? So that is the use of the subnet mask. I hope it is clear. Right, so we will do this example, then you will easily understand what is the meaning. No need to write this down, right? So this is very clear what is actually happening. Okay, right. So we'll look at this example. Assume now assume now here you have 15.100 is the IP address, right? But here we have divided this IP address into two now, right? 150.12.0 and 12.128, right? A subnetting has happened. So this one address, 150.100, now you have two networks, right? This network and this network, right? One network ID is 12.128. The other one is 12.0, right? So this one address, now we have divided into two, right? Assume a packet arrives with the address 150.100.12.176, right? So this packet, this IP packet is coming from here, right? Now this router wants to understand whether you should send it to this network or this network, right? You have to send it to this network or this network, right? So what do you do? You take the IP address and then the subnet mask and do this AND operation, right? You do the AND operation. Then you will get 150.100.12.128, right? So this network ID you will get as the final. It's a small correction here. Please make this not subnet mask. It should be a network ID. Right, please correct it. Right, so from the AND operation, you will get the final answer as 150.100.12.128. The router knows, right? So router has two interfaces, no? So it knows this interface is connected to this 12.128 network. This interface is connected to 12.0 network. So then it will route the packet to this side, right? So that is the purpose of the subnet mask, right? Always the packet will be sent with the subnet mask detail. So then any router can perform this IP address and subnet mask operation and figure out the network ID and then forward it to the correct network. Okay. So that is the purpose of having a subnet mask.
Excuse me, madam.
Yes.
Madam, subnet mask එක චුට්ටක් ආපහු explain කරන්න පුළුවන් මම.
Subnet mask එක කියන්නේ මොකක්ද කියලාද? Subnet mask එක මොකටද ඒක use
ගන්න
කරන්නේ?
කොහොමද madam මේක?
ඔය ගන්න මෙහෙමයි. දැන් ඔයා දන්නවනේ අපි දැන් දන්නවනේ network එකේ ඔයාගේ network bits ගාන කීයද කියලා. දැන් මේකේ උදාහරණයක් වශයෙන් ගත්තොත් network bits මේගොල්ලෝ මෙන්න මේගොල්ලෝ network එක හදන්නේ මෙතනින්. wait. දැන් මෙයාලගේ network එක 150.100. හරිද? එතකොට මෙයාට host එකට මෙයාගොල්ලන්ගේ තියෙන්නේ host they have only 100 host, right? 100 means how many you will need? 7, right? You will need 7, no? 100 means 128, no?
Yes.
So 7, right? So
Seven.
then
Seven.
you can use all these bits, right? Now here the network is 150.100, no? So you have 1, 2, 3, 4, 5, 6, 7, 8, and then again 1, 2, 3, 4, 5, 6, 7, 8, right? All these X values, you can do whatever you want, right? Remember, because in this network ID, they are given only 2. This is the part that is static, 150.100. Anything else you can do inside your network, whatever you want, you can do. Now, the issue is they want only 7, right? So they cut here. They can cut the network and the host at here, right? Because they only want 7 here, right? So then this part will be what? As we discussed earlier, the subnet part, right? So this is also becoming now the network part, right? Now the network part will be 150.100. This whole thing again is network, right? So then this last 7 bits are the host ID. This whole thing is the network ID. Now I'm explaining this example because the previous example now I don't have, okay? So then the subnet mask will be all these network IDs you put 1. So then how many network digits in this one? First letter. First number means 8 digits here, right? 150 means there is 8 digits. So all 8 digits you put 1. 1, 2, 3, 4, 5, 6, 7, 8, right? Then again here also you have 8 digits. Which are the network digits? 1, 2, 3, 4, 5, 6, 7, 8, right? Again, there are 8 digits here. 1, 2, 3, 4, 5, 6, 7, 8, right? And then finally, at the final 8, how many network digits you have? Out of this final 8 ones, how many are network digits? If you divide the network and host here, 1, right? Only first one, right? So you put that also 1. And then others are 0. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Right? So this is called the subnet mask. Right? All the network digits are converted into 1. Understood? Now the advantage of this is if you get any IP address in this 150.100 something, right? Let's say 150.100.192. something. 192.10. Then you want to find out which network this is belonging to. Now, because this IP address comes to this 150.100, right? You come here, so you come to this network. Now, this network also we have divided into 3 other networks. Now, this router here wants to understand when this 150.100. something 192.5 IP address comes here, whether you should send it to this network or this network or this network, because Earlier, there was only one network, 150.100, right? Now we have created out of this IP address 3 other separate networks. Now the router wants to understand whether I should send it this way, or this way. So to do that, what you do is you take the IP address and the subnet mask, and then you do AND operation. And then you will get the network ID. Then you can decide whether you should go this way, or this way. Understood? So basically to get the network mask, you have to do is convert all the network bits to 1. Then you will get the network mask. Okay. So that is what I did on this slide and showed you that you can get the network address, right? And this example shows you why it is required. Right, so let's say this 150.100.12.176. Now, looking at this part, you should be able to understand whether now there are 2 addresses. No, 150.100 is divided into 150.100.12.128 and 150.100.12.0. Now, looking at the decimal numbers, we can decide, okay, if it is 12.128, definitely this should be in this network. But you are looking at the digital, like the digits, right? Decimal values in the computer. So the computer cannot understand. So it will do this AND operation and come to the conclusion, okay, this has to go to this network. So to find out from here whether you should go here or here, you have to do AND operation of the IP address with the subnet mask. So subnet mask means how many network digits, right? How many network digits. So usually in IP address, it will be shown like this, right? So here we are talking about classless interdomain routing or CIDR, which I tried to explain you by all this subnetting. That is what I wanted to tell you, right? So we now don't stick into 8 digits network or 16 digits network. Now, whenever you want, you can decide, okay, I'm going to use 20 digits for network or 15 digits for network, as I showed you in this subnetting example. You can make the decision. So when you make the decision with the IP address as a slash, you show how many network bits, right? So for here example, they are saying 20, right? 20 means here 8. Sorry, if you take 3, then it will go to 24. No, yeah, they are only using 20. So that means 8 here, 16 bits. And these 4 bits in the third number you are using as network ID, right? So that is the meaning of this, right? 20 means you are using 20 bits for network. 192.4. This one, right? So that means your subnet mask will be 111111 111111 1111 right? So from this, the computer can understand what is the subnet mask length, right? So by doing this, like not sticking into 8 digits or 16 digit system like the class full system, when you go with the classless system, which I explained you through the subnetting, then we can utilize the IP addresses better, right? So that is the point you have to take. So in the IP address, if you are not using now, if you just say, for example, 192.4.16.23, right? Or something without the slash value, right? Without the slash value, if you just show like this, that means you are going in the class full system, right? So class full system means no need to say no, you know. 192 means class C. That means you have 16 first 3 is the network part, this is the host part, right? But if you are not adhering to the class full system, then you show like this, right? If you are going for classless distribution between network and host IDs, then you show it, right? If you don't mention by the slash, then that is assumed that you are going in the class full system. That means 192 means class C, that means 3 network IDs. Or 3 digits for the network, 1 digit for the host ID, right? If not, if you are using a classless system or you are using subnetting, then you show it like this. So this classless system enables more efficient of address space, right? So the prefix has to be sent with the IP address for the routers to identify the network ID, right? So that is why I told you with the IP address, you have to show this slash number. From the slash number, the network will, the router or the any device will understand what is your network ID, because they can easily get your subnet mask. 20 means 1111, 20 ones, right? And the others are 0. So then they quickly do that AND operation and find out your network ID. Okay. So if you don't show this, then it will be assumed you are going in the class full system, right? So is it clear? So this is the same example that I have already showed you. So you can look at this, right? So they are using these ones. If you are using 20, that means you are going up to here. Right? Then after that also, if you want to further do, then you can use some additional ones and again do a subnetting, right? So let's say your IP address is this. You are given this 20 IP address. That means up to here is the network. Then if you want to divide this further into several organizations, then you can take additional 3 digits and then do a subnetting and do it. Okay. So the same thing that we discussed. The same thing. Right. So is it clear? I'm going to stop here because what we have discussed is little bit tricky. So you will need some time to gather and anyway discuss. Right. So then, students, I will not be taking the lighting lecture because there will be a power cut in my area. So I don't think I will be able to join because the network quality is also not very good. Okay. So we will not do the lighting lecture today. I will put an additional time later for that. Right. So if you don't have any questions, we can wind up from here. Then I will see you next week for the lecture. Sorry for cancelling the lecture in the last minute, but I don't think I will be able to do it properly. And if I like continuously get disconnected, that is also an issue. So we will not do the lecture today. I will see you next week for the next lecture then. And then now next week we are supposed to do the quiz, right? Next week we agreed for the quiz, right? Right? Yes. Again. නෑ මෙහෙමයි මම Google ෆෝම් එකක් දාන්නේ. ඒතකොට ඔයගොල්ලන්ට ලැප් එකකින් යන්න ඕනේ නෑ, ෆෝන් එකෙන් ගිහලා කරන්නත් පුළුවන්. හරි? මම සාමාන්‍යයෙන් කරන්නේ විනාඩි පැය භාගයක්නේ දෙන්නේ. මම ඕපන් කරනවා Google ෆෝම් එක පැය භාගයක්. ඒ පැය භාගය ඇතුළත ඔයගොල්ලෝ කරන්න ඕනේ. කළා පැය භාගයෙන් Google ෆෝම් එක ක්ලෝස් කරනවා. එහෙනම් තමයි කරන්නේ. මොකද දැන් ඉෂුව එක ලැප් ෆෝන් එකකින් කරන්න පුළුවන් කිසි ප්‍රශ්නයක් නෑ. නෑ LMS එක කිසි සම්බන්ධයක් නෑ. Google ෆෝම් එකක් තියෙන. අපි ඔය සාමාන්‍යයෙන් ඔයගොල්ලන්ගේ එක එක මේ සර්වේස් කරන්න එහෙම ගන්න Google ෆෝම් තියෙන. ඒ කියන්නේ අර මේ Excel එක නෙවෙයි. ඔයගොල්ලෝ දන්නවනේ සර්වේස් කරන්නේ අපි අර ගිහලා සිලෙක්ට් කරන් තියෙන. ඔව්. නෑ LMS කතාවක් නෑ. LMS එකත් ඔක් කරන්න බෑ. Google ෆෝම් එකක් දාන්නේ. මම link එක දැන් link එක ඔයාලට link එක එවලා ඉවර වෙලා අර ඒකේ පුළුවන් ඕෆ් කරන්න ඕන් කරන්න response ගන්න එක. එතකොට response ගන්න එක on කරනවා පටන් ගන්න වෙලාවට. එතකොට පැය භාගකින් response ගන්න එක close කරනවා. එතකොට ඒ වෙලාව ඇතුළත ඔයගොල්ලෝ කළා submit එක පැය භාග කියන්නේ විනාඩි 5ක් විතර වැඩිපුර දෙනවා. ඊට පස්සේ close කරාම ඒ වෙලාවේදී ඔයගොල්ලෝ submit කරලා තියෙනවා. හරි Google form එක. ෆෝන් එකෙන් කරන්නත් පුළුවන් laptop එකක් ඕනේ නැහැ. ඔව්. එහෙම වුණොත් අඩු version එකක් දාන්න. ඒගොල්ලන්ගේ තව අඩු versions උත් තියෙනවා dialogs එකේ. මෙහෙම dialogs වල අර original dialogs කියන එක නම් ඇත්තටම දැන් කරන එක තේරුම් නැහැ. ඒක ගොඩක් අය දැන් පාවිච්චි කරන්නේ dialogs evo තමයි පාවිච්චි කරන්නේ. evo එකේ අඩු versions තියෙනවා. ඒ කියන්නේ ඔය මම latest version එක ඔයගලන්ට පෙන්නුවේ ඉන්ටර්නෙට් එකේ පොඩ්ඩක් search කරලා බලන්න ඊට අඩු versions තියෙනවා. චුට්ටක් බලන්නකෝ ඒකක් දාගන්න පුළුවන්ද කියලා. ඔව්. එහෙනම් බලන්න ඊට වඩා පල්ලෙහා version එකක් දාන්න. මොකද එතකොට වෙන්නේ පොඩ්ඩක් features අඩු වෙන එක විතරයි. අර ඔයගොල්ලෝ පාවිච්චි කරන විදිය same නේ. අර ඊට වඩා ගොඩක් අඩු මේකෙන් කරන්න පුළුවන් normal dialects එකේ. දැන් ඉතින් ඒක පාවිච්චි කරන එක තේරුම්න්නේ ඒක ගොඩක් අය දැන් use කරන්න ඒක දැන් සාමාන්‍ය අවුරුදු 3ක් 4ක් පාන්න software එකක්. ඉතින් ඒක කරන එක තේරුමක් නැහැ. පොඩ්ඩක් බලන්නකෝ අරක දාගන්න අපිට මම පොඩ්ඩක් time දෙන්නම්. හදිස්සියක් නෑ නේ ඒක අපිට කරා. මේ පොඩ්ඩක් බලලා කියන්නකෝ මට ඒක. මේ කියන්නේ අඩු version එකක් දාන්න බලන්නකෝ. එතකොට සමහර විට ඕකේ වෙයි. එහෙනම් next week එකේ මේ අපි lighting lecture එක පටන් ගන්නකොටම ඉස්සෙල්ලා ඒ කියන්නේ උදේ ancillary කරලා lighting lecture එකේ උදේ කියන්නේ අපි දැන් එකටනේ සාමාන්‍යයෙන් පටන් ගන්න එකට විතර half an hour අරගෙන quiz එක කරලා තමයි lecture එක කරන්නේ. Okay? Yeah, I will end the lecture from here. Thank you everybody for joining.